Hey, good morning. My name is Kieran McManus. I'm the BIM Survey Manager for Mercury Engineering. When we heard about the CITA Collaboration Challenge a couple of months back, it was a perfect opportunity for us to develop some of the ideas that we had talked about. Wouldn't it be great if we could kind of ideas? It gave us the perfect avenue to look at some of these. So the title of our challenge over the past week was Laser Scanning for Virtual Building. So this took the problem of an industrial refit project and how background condition model is currently developed and used for an M&E refit. So the problem we read recently by modelling to a scan cloud that you effectively change the geometry and the spatial accuracy of the point cloud. So you're better off to just use the cloud itself. This gets rid of the problem of spatial inaccuracies, missing elements, and it gives you an easier and quicker way of working because you don't have to carry out the task of the modelling procedure. So our team is made up of myself, from Mercury Engineering, Kieran McCrary, Cathal O'Doherty, Aidan Campbell. From the DIT we have Dr. Avril Bean, Jonathan Argue, Jennifer O'Connor, Harry Toomey. And we also have included as part of our team our software partners, Intergraph, and we had Chris Parkin over from the UK for a couple of days, and he did a handover on Wednesday with Michael Smith. I'd like to thank Michael for flying in from Houston at short notice to lend his support to our challenge. So the solution that we wanted to look at came in three separate strands to reach one ultimate goal of a semantic point cloud. We wanted to develop, with the aid of the geoinformatics students from Bolton Street, a surveying workflow. What we would do is we would detail our current workflow, how it is we operate at the moment, and we would develop that to include laser scanning operations to take full account of everything we do at present. We would develop a BIM survey specification, which would act as an in-house standard operating procedure document and will give guidance to outside subcontractors. And the final and most exciting part of the week for us was the development of a data management and interface application that would allow us to utilise semantic point clouds in our preferred software application. So the first thing we did was we got together with our lean and innovation people, and we had a look at the current workflow that we utilise for capturing as-is information from the field. This process has two distinct and separate operations based on tasks. The first is for connection detailing, where we take a total station into the field and we shoot connection points. So we produce a CSV file with a single point, which is then brought into our software and is given some semantic data so as we know what the valve is we're connecting to. The second part of the process is we have a laser scan survey, which is completed by a third-party organisation, which provides us the background for effective clashing and route detection. So we wanted to take our current workflow and combine both of them. So what we did was we produced a workflow that allows us to capture all the information from both tasks in one operation. So this reduces time and visits to the field. We performed a SWOT analysis on our new workflow, so that we could recognise its strengths, its weaknesses, its opportunities and its threats. We looked at the idea of one visit to capture all the data in a particular area, which will give you increased scope that you don't have to revisit your area, which will lead to extra time. It reduces your chance of rework. For us as well, it would be an opportunity to develop an in-house capability that we could produce our own laser scans, so we don't need to rely solely on a third-party vendor. The weakness that we identified was the scanning process takes longer. So where we can effectively capture our connection details in particular quite quickly, this would give us added time, but it would give us far greater scope and detail to connect correctly to a particular valve. Our opportunities: we can use the information that we collect for more than the intended use at present. For example, we can use it for progress tracking. We don't need to, like I mentioned already, we don't need to rely solely on a third-party vendor. We can take some of the responsibility ourselves. and we can produce, which is the most important opportunity, is an accurate background conditions model, which will mitigate risk and allow us to achieve right first time construction. So some threats we identified, normal surveying threats, which we can have insufficient control data, we can have issues with file sizes, and not all the data may be captured. So planning is crucial, which was identified in our workflows. So to feed into our workflow and to develop that further, we produce over the course of the week a BIM survey specification, which, like we said, would act as an internal standard operating procedure document and also give guidance to third-party providers on what it is that we may expect to receive. So just it's not working for me. Actually, I just wanted to take a quick look at the headings that we developed over the course of the week. The most important thing, the thing we had in first was point cloud quality parameters. So we did an awful lot of testing over the course of the week on level of detail of point clouds, which is something we'll speak about in a moment. The students took some laser scanning equipment down to one of the labs in the basement in the DIT, and we scanned some valves at various resolution settings to see what the most appropriate for various tasks would be. We looked at exchange of information, how point cloud data is passed between either the in-house surveyors or the third-party vendors. So this document acts as a very generic template for project-specific development at a later date based on need. So from the point of view of exchange, we've looked at encrypted hard drives, we've looked at shared network drives, and we've looked at the idea of secure cloud storage, which would allow us to work remotely. We've also taken some information on standards, applicable standards for laser scanning and surveying products, and the standard of equipment and testing that would be expected were we to receive this information. So our level of detail investigation, we wanted to look at the point cloud for a number of different purposes. So we wanted to look at how it would operate for connection purposes, and we wanted to look at how it would operate for routing and clash detection purposes. So obviously for connection detailing you would need a high level of detail. So you can see on the far left the high resolution scan that was completed. So the guys took some considerable time to work through the machine and the different settings and come up with what we all thought was the most appropriate high level detail scan. The resolutions, the required range of resolutions are included in the documents to give guidance on what's required for that particular purpose. So medium density scans are required for routing to avoid clashes. So again, there was some testing done to see which gave us the best definition around pipework, and we looked at some congestion and how that affects the level of detail as well. So this all fed into the main goal, and the ultimate thing that we wanted to develop across the course of the week was a database-driven interface between our point cloud data and our modelling software. So taking the scan data that the guys captured in the basement, that was fed into a machine, it was registered and it was processed. The information centred around the valves was then geotagged to give all the data of the valve to those particular points in the cloud. Now, while this is a very specific M&E application, this kind of method of working and geotagging can be used for any discipline. It's not specific to M&E industry. It can be used for any form of engineering or architecture, or for data capture in general. So the geotagged data was then pushed out to a database. We could also push the scan cloud to a database and attach the appropriate attribute data later. A query was developed which would create a new point cloud and draw that into CADWorks. Now, we had hoped over the course of the week that what we would do was we would figure out how it is that we could do this, and we would develop a roadmap that we could implement this further down the track with the help of Intergraph. However, thanks to some fantastic work across the course of the week, we managed to get a working prototype by Thursday evening. So it was a short, it may be slightly difficult to see, it's down at the bottom of the page, but essentially what we developed was a working prototype where the information was added as we discussed through the database. Query was set up. The point cloud that was then brought into CADWorks had all the appropriate information attached to a region of points in the area of the valve. This could then be exported through an NWC command into Navisworks. All the attributed data came with it, and you could view the created model and the attributed model in Navisworks. So this gave us the opportunity that we could develop what it was we were after. So I'm going to hand it over to Michael Smith, who's going to speak about some Intergraph applications and point cloud innovation.
Thank you, Karen. Well, this has been an exciting week, and I'm really honored to be here with you all. As Karen indicated, this is really talking about point cloud innovation and how point clouds can be modified or enhanced to serve the business need, thereby driving more information back into the project. So with that said, the two images that you see on the right, the photograph and the point cloud, thanks to our sister company Leica in the back. This allows us to see the point cloud two different ways, but we are registered, or these two images or data are interrelated, such that we can actually see much more clearly the content of the project or scope of work. Yet we can leverage the photograph and the point cloud together so that we can clearly see what needs to be geotagged with the advanced technologies that Leica technology brings. And with that said, here is a visual aid of what geotagging looks like. We're using the photograph, but yet we are tagging in XYZ within the point cloud and assigning or defining nodes of information. And as Karen intimated too, the attributes are added and then brought back into the point cloud. And so here I have a small video that might give you some idea what this geotagging feature actually looks like. But I think the significant thing, or the bottom line result of this week's effort, and I must compliment everyone's efforts from Mercury and DIT and student activities, was a Herculean effort to achieve an innovation in point cloud development. But where am I here? Let me run this video and you'll get some idea. Here we can filter by the valve number schema and drill down on some of the specific information within the actual point cloud. But here you see it through the photograph. We find the IDs, the unique identifiers, and with that then we can examine further information as a result. But the whole idea is that we can move through the point cloud visually with very good clarity through the photograph, yet we are in the point cloud data set and filtering to find the unique geotags. So if they need to work on this valve or that valve, this piece of equipment or that asset of the facility, they can actually locate them in space. And then the ability to then link additional information, such as in this case, schematic information such as P&ID or process and instrumentation diagrams, and ultimately to link, if you will, equipment information such that a facility's maintenance and operation application is now part of that eventuality. The bottom line is that we at Intergraph are very excited about the results of this workshop, in that now with the collaboration between industry, academia, and development, we are now looking to bring this new capability into our software and bring it to the entire BIM community. So I think it's exciting that the CITA activity, the CITA challenge, is actually driving new product development. And on behalf of Intergraph, I'm really excited to be here and see this kind of innovation occur. So I'd also like to finish, if you will, with thanking CITA for organizing this. I think this is a tremendous venue and forum. All of you have done tremendous things this week. It's just exciting. And I would like to have you all join me in a good round of applause for the leadership here.
So, again, following precedents from the earlier session, do we have any questions here for this team? While we're waiting for them to get a microphone, Alan. Yes. Alan, here.
I'll ask the question. You mentioned
No, there's just. Right.
You mentioned that the industry was engineering specific. Where would you have seen the benefits across the architectural arena from the lessons you've learned this week?
Well, we were speaking to one of the judges on Tuesday evening, and he asked a similar question. So it comes back to the idea of by modelling from a point cloud, you change the spatial accuracy of the object as it is in the field. So it doesn't matter if it's an M&E valve, or it's a window or a door or a structural column. It's still the same idea. So if you can add the characteristics of that window or valve or column to your point cloud, you can use that and you can model in the point cloud as opposed to developing a solid object.
And Kieran, are you with the tagged point, the point cloud with the tagged data in it? Are you actually at the point, given the optimum scanning, are you actually at the point that you can actually start to automatically produce isometrics from it for prefabrication?
Well, that's maybe a question for Michael from Kieran.
Can you? Yes, it's on. It's on.
Sorry, no,
Good. Sorry,
so essentially, with the application as we've developed it, it gives us increased confidence and increased accuracy over isometrics that we would produce. As Kieran's alluded to, we've taken out that interim step where something has been translated from a point cloud to a solid.
Yes.
Hence changing it,
Yes.
and introducing an error. So we would proceed with increased confidence that the ultimate output, be it an isometric or whatever prefabrication element, would come out with increased accuracy.
And I presume the dimensions on the solids that you're geotagging into the cloud, that they actually would help you in producing accurate isometrics. The fact that you have, yes.
Absolutely, rather than a representation of an item, we have the actual.
Yeah, we have to actually leverage the manufacturer's data.
Sure.
Leveraging their 3D capabilities, yes. Incorporating vendor data directly into the model, so we had exacting geometry.
Wonderful. Any other questions here? Sorry, Alan?
Sorry, hands up.
Alan was on to his bookie there to Paddy Power.
So
The races in Clonmel this afternoon.
I was just going to ask, as a contractor, how are Mercury going to take this forward?
Well, we've developed a prototype over the course of the week, so we can start to implement this now across our modelling workflow, and we can look at how originally we didn't think we would get this far, that we would have a working prototype, and what we wanted to do was develop a roadmap for implementation and further development so that we could actually get a product that worked. But we have a product now that works, so our next step over the next week or two will be to see how we integrate that into our current applications. It'll be most likely through a pilot project over the next week with a select number of detailers to see how they can best utilise it. and we'll give it to some of our best-in-class detailers, and we'll see how they can use it appropriately, and we'll start to, from their feedback, then we'll start to get how we proceed from there and how it's implemented to the entire organisation and the group. So.
Thank you, Kieran. And
Okay, one more.
So, sorry, one more. Sorry.
So just one quick question, Kieran. Have you further expanded into see if you can identify cloud components via libraries so that you can actually further the fabrication process?
We didn't look at the idea of automatic identification. What we looked at, one of the tests we conducted was how we would identify the valve manually from the point cloud. So we did some tests with some low-tech object recognition to see how we would identify. But we didn't take the step of automatic shape recognition. But that's something that Intergraph offer as a service at the moment, and we can look how we would do that, how we would implement that into the prototype that we've developed.
Good. Thank you, Kieran, and well done. This is certainly something I see.